Hello everybody, welcome back to Ethiopedia by Desu Birchit. Today we will discuss three types of functions: one-to-one function, on-to function, and one-to-one correspondence function. Let's dive into the first type. If each element in the domain of a function has a distinct image in the codomain, then that function is called one-to-one function or injective function. Injective function is the other name of one-to-one function. From the definition of function, we know that one value in the domain can't pair with two or more different values in the codomain, but two or more values in the domain can pair with one element in the codomain. If it is one-to-one function, such mapping, meaning a mapping from two or more domains to a single range or codomain, is impossible. The word or the concept which we didn't come across in the previous installments of this series is codomain. Let's define what it means. Codomain of a function is a set into which all outputs of a function is constrained to fall. It's a set of values that could possibly outcome. Sometimes codomain is the same as range, but some other times it's different from range. The codomain is the set of all possible values which can come out as a result, but the range is the set of values that actually comes out. Let us illustrate the difference and similarity between codomain and domain by using diagram. The diagram below stands for the values of x that are 2, 3, and 5, and the values of y 4, 9, 10, and 12. Assume f is a function that maps from x to y, 2 relates to 4, 3 relates to 9, and 5 relates to 10. Let's find the domain, codomain, and range of this function. Domains are values of x, or we call them input values, or values residing on the side where the arrow starts. These are 2, 3, and 5. Codomains are values of y, or the possible output values, or those values situated on the side towards which the arrow points. These values are 4, 9, 10, and 12. Ranges are values in the codomain which relates to at least one value in the domain. 4 relates to 2, so it's part of the range. 9 associates with 3, thus 9 is part of the range. 10 has a pre-image in the domain, thus 10 is also part of the range. 12 doesn't relate to any value in the domain, hence 12 is not in the range. This example shows the difference between range and codomain clearly. Both of them are values of y. All y values, regardless of their relation with x value, are codomains. Ranges are those y values or codomains which have at least one pre-image in the domain. In this diagram, every x value maps to a single value in the codomain, meaning the relation is one-to-one mapping. Thus, this function is one-to-one or injective function. Functions not always expressed in the form of diagram. Rather, we can express them by using equations, set of order pairs, graphs, word problems, and so on. But most commonly used ones are equations. We have one important definition that helps us to check whether a given function is one-to-one or not. A function f is one-to-one if and only if f of x1 equal to f of x2 for all x1 equal to x2, or f of x1 not equal to f of x2 for all x1 not equal to x2, given that x1 and x2 are elements of the function. These two definitions or these two expressions are one and the same. Let's see how these definitions work. Let f is a function maps from natural number to natural number where f of x equal to 2x cubed minus 4. Determine if f is an injective function. Let's start with the assumption f of x1 equal to f of x2 and then prove for x1 equal to x2. F of x1 means rewriting the equation by replacing x with x1, and f of x2 means rewriting the equation by substituting x by x2. Thus, f of x1 is 2x1 cubed minus 4 equal to f of x2 is 2x2 cubed minus 4. To eliminate negative 4 from both equations, we can add the opposite of negative 4, which is positive 4. That's 2x1 cubed minus 4 plus 4 equal to 2x2 cubed minus 4 plus 4. The equality holds on because we add the same number on both sides. Negative 4 plus 4 is 0. So we have 2x1 cubed equal to 2x2 cubed. 2 cross out by 2. Thus, we have x1 cubed equal to x2 cubed. Let's take the cube root of both sides of the equality. Cube root of x1 cubed is x1 equal to cube root of x2 cubed is x2. We assumed f of x1 equal to f of x2, and we reached to a conclusion x1 equal to x2. Thus, f is one-to-one or injective function. The second type is onto or surjective function. A function is called an onto function or surjective function if each element in the codomain has at least one pre-image in the domain. At the beginning of this section, we discussed that if the element in the codomain has at least one pre-image in the domain, that element is part of the range. This definition states that a function is onto if each element in the codomain has at least one pre-image in the domain. These two definitions tells us that a function is onto only when the codomain and the range of a function are the same. Again, let's elaborate this definition by using diagram. The diagram below represents x and y with values of x equal to 10, 20, 30, and 40, and values of y equal to a, b, and c. Assume h is a function that maps from x to y. 10 relates to c, 20 associates with b, 30 relates to a, and 40 relates to b. From the given diagram, we can find the domain, codomain, and range of function h. Domains are values of x, which are 10, 20, 30, and 40. Codomains are values of y. These are a, b, and c. Ranges are values in the codomain, which relates to at least one element in the domain. All values in the codomain are related to at least one element in the domain. A relates to 30, B relates to 20 and 40, and C relates to 10. Therefore, all values of y or all values of the codomain are part of the range. Since each element in the codomain has at least one element or pre-image in the domain, this function is surjective or onto function. Element B in the codomain relates to two different elements in the domain. B relates to 20 and B relates to 40, meaning h of 20 equal to h of 40 equal to B, but 20 is not equal to 40. In other words, this function doesn't fulfill the requirements of one-to-one function. Thus, h is not one-to-one or injective function. Third category is bijective or one-to-one correspondence function. A function is called one-to-one correspondence or bijective function if it is both one-to-one function and onto function. Let's illustrate on this definition by using diagram again. The diagram given below are x and y. Let h is a function that maps from x to y, and -1 relates to -10, a maps to b, and 1 associates with 10. As usual, let's find the domain, codomain, and range of this function. Domains are input values or values of x, which are -1, a, and 1. Codomains are values of y, b, -10, and 10. Ranges are values of y associated with at least one element in the domain. All values in the codomain are related to at least one element in the domain. Thus, range is simply equal to the codomain of the function. Since the range of this function is equal to its codomain, it's an onto or surjective function. Each element in the domain maps to only one element in the codomain. Therefore, H is one-to-one or injective function. H is bijective or one-to-one correspondence function because it is both injective and surjective function. Let's solve some more questions so that each of these functions is stuck in your mind and you will never forget them. Identify if the following functions are injective, surjective, and or bijective. Question number 1. G is a function maps from rational number to whole number where g of x equal to -3x plus 7. First, let's check if this function is injective. The requirement for injective function is g is injective if and only if g of x1 equal to g of x2 for all x1 equal to x2. G of x1 means simply substituting x1 in place of x, that's -3x1 plus 7 equal to g of x2 means replacing x with x2, that's -3x2 plus 7. We have plus 7 on both sides of equality. If we deduct 7 on both sides of the equality, we can remove plus 7, meaning -3x1 plus 7 minus 7 equal to -3x2 plus 7 minus 7. 7 minus 7 is 0. So we left with -3x1 equal to -3x2. -3 crossed out by -3. Thus, what we left is x1 equal to x2. We assumed g of x1 equal to g of x2, and we proved that x1 equal to x2. For all x1 equal to x2, g of x1 is equal to g of x2. Therefore, g is a one-to-one function. Function g is surjective if we can find at least one x for every y. To prove that, let's substitute g of x by y and write x in terms of y, meaning g of x is simply y equal to -3x plus 7. If we take plus 7 to the left of equality sign, it becomes -7. So the equation becomes y minus 7 equal to -3x. To remove -3 from the coefficient of x, we have to divide both sides of the equality by -3. -3 crossed out by -3, so we have x equal to y divided by -3 is -1/3y. -7 divided by -3 is +7/3. It's stated in the question that y is whole number and x is rational number. If we substitute any whole number in place of y, we can find the value of x, and that value is rational number. We can check it with 0, 1, and 2. If y equal to 0, x equal to -1/3 times 0 plus 7/3, which is equal to 7/3, because -1/3 times 0 is 0. 0 plus 7/3 is simply 7/3. If y equal to 1, then x equal to -1/3 times 1 plus 7/3. -1/3 times 1 is -1/3. -1/3 plus 7/3 gives us 6/3, which is equal to 2. If y equal to 2, x equal to -1/3 times 2 plus 7/3. -1/3 times 2 is -2/3. Negative 2 over 3 plus 7 over 3 is 5 over 3. For every whole number y, we can find a rational number x. Therefore, g is surjective function. Conversely, if x were whole number and y were rational number, function g wouldn't be surjective function because we can't find whole number x for every rational number y. Even here, from these three results, 7 over 3 and 5 over 3 are not whole numbers, rather they are rational numbers. In other words, there are rational numbers for which we can't find their pre-image in the domain. Since G is both injective and surjective, it is bijective or one-to-one correspondence function. Question number 2. F is a function mapped from positive integer to natural number where f of x equal to ax square minus 3 and a is a non-zero integer. F is injective if and only if f of x1 equal to f of x2 for all x1 equal to x2. F of x1 is ax1 square minus 3 equal to f of x2 is ax2 square minus 3. To eliminate minus 3 from the equation, let's add 3 to the equation. This implies ax1 square minus 3 plus 3 equal to ax2 square minus 3 plus 3. Minus 3 plus 3 gives us 0. So we left with ax1 square equal to ax2 square. Letter a cross out by letter a. Thus x1 square equal to x2 square. Taking square root of both sides gives us x1 equal to x2. F is injective or one-to-one function because we started with the assumption f of x1 equal to f of x2 and we proved that x1 equal to x2. F is surjective if there is at least one x for every y. Substituting f of x with y gives us y equal to ax square minus 3. Taking minus 3 to the left of equality gives us y plus 3 equal to ax squared. Dividing both sides by the coefficient of x squared gives us a cross out by a, thus x squared equal to y divided by a is 1 over ay plus 3 divided by a is 3 over a. If we take the square root of both sides, square root of 1 over a times y plus 3 over a equal to x. It's given that y is natural number and a is a non-zero integer. If y is big natural number and a is small negative numbers like negative 1, the value in the square root becomes negative. That's undefined because the value in the square root always be positive. This means for some y values, we can't find x value, meaning for some values in the codomain, we can't find a preimage in the domain. Thus, f is not surjective. Since f is not surjective, it's not bijective because bijectives are both injective and surjective. Question number 3. X equal to a set containing these 4 elements and y equal to a set containing these 3 elements. F is a function from x to y, where f of 2 equal to 4, f of 3 equal to 10, f of 5 equal to 10 again, and f of 7 equal to 14. To check whether f is injective, surjective, or bijective, let's express the function in the form of diagram. These two diagrams represent x and y. Values of x are 2, 3, 5, and 7. Values of y are 4, 10, and 14. Given that f is a function from x to y, f of 2 is 4, f of 3 is 10, f of 5 is also 10, and f of 7 is 14. In this diagram, both 3 and 5 map to 10, meaning f of 3 equal to f of 5 equal to 10, but 3 not equal to 5. Therefore, f is not injective function. Every element under Y or under codomain has at least one pre-image under X. Hence, f is surjective function. F is not bijective because it is not injective. That's all for this part. Thank you for your attention. Take care and stay safe.